to help us for some formulas. A sequence is just an ordered progression of numbers. And by an ordered sequence of numbers, I mean that you can really do anything that you want with them. Let me give you some and see if you can figure out the patterns. Then we're going to talk about what it means to be specifically arithmetic or geometric. Let's see if you can figure this one out. I'll start with a hard one.
Oh, it's not, I don't know.
Shh, stop it. Yeah, what's going on with this one? Yeah, this is actually a pretty famous one. It is adding the previous two terms. You start with a 1 and then you have a 1. 1 plus 1 is, 1 plus 2 is, 2 plus 3 is. Interesting. But is it arithmetic or geometric? It is not. Here's another one that's interesting. Let's see if you can figure this one out. Ooh. That's a 2. Do you want to give you another one?
Yeah.
Want me to give you another one? That is true. Can somebody tell me in general if this is the first term, and this is the second term, and this is the third term, and this is the fourth term, and the fifth, and the sixth, and the seventh, how would I find the nth term? Okay, what's 1 squared? What's 2 squared? What's 3 squared? What's 4 squared? What's 5 squared? What's 6 squared? What's 7 squared? So in general, isn't the nth squared plus 1? I was squaring the terms and adding 1. Okay, this is a really good example of what we call explicit. Explicit means I can have a formula for the term, and this is a good one for recursive. And recursive is we're basing the sequence based on what the previous terms were. And so let's take something and write it explicitly versus recursively. So I'll take the same one. Well, I'm going to do like a arithmetic one now. This would be the explicit formula for this one. If I'm saying to find the nth term, I would write a sub n equals n squared plus 1. This just means the nth term equals, you take the term number and you add 1. So this is a good example of explicit, but we're going to talk about it with arithmetic and geometric in a second. Let me just show you what the recursive formula for this would be, this above one. From last year, we would state what the first term was, and the first term is 1. And we would say, how are we finding terms? Well, what we do is we take, I'd write it this way. I would take, I know.
He really wants to come in. So excited.
Okay. So what I'm saying, I'm recording. Unless you want to say I'm on the recording, now he is. All right. So what this means is to find the n plus 2 term, you take the term before and the term before that, because n plus 1 was 1 before n plus 2, agreed? And n is 1 before that. Okay, let's talk about this in terms of just an arithmetic sequence and series. So if I had the sequence -1, 4, 9, 14, 19. This is arithmetic. Arithmetic means what? There's a constant difference. You're adding something or subtracting something in between the terms. The way that I would write this explicitly, we call it the explicit formula. It's right on this piece of paper. Is I would write a sub n equals, what does a sub 1 stand for? The first term. What's the first term? -1 plus n minus 1 times d, so I'd have to figure out what d is. D represents what's being added on, which is 5. And then I would simplify it. If I distribute this 5 to these things, do you see I get 5n minus 5? So I could write it then as a sub n equals, let's see, -1 plus -5, -6. Alright, so this would be 5n minus 6 if I were to distribute that and simplify it. What this tells me is, if I wanted to find the 100th term, I actually could put in 100 instead of adding 5 a bunch of times to get there. Does that make sense? Okay. The recursive formula, again, the recursive formula is right on this gold sheet. Always has 2 parts, at least 2 parts. A sub 1 equals the first term, so we would write -1. A sub n equals a sub n minus 1, that just means the previous term, plus, what are we adding each time? 5. One thing we should add to this is, just so we know what n is the term number, so it starts at the first term, right? So I would say for n, for integers, because we don't have like the 1.2 term, n greater than or equal to 1. Okay. So, this is arithmetic. We should also talk about geometric. Oh, we should, gosh, you guys probably did all this before. Did you find, like, if I told you what the term was, how do you find the nth term? Or what term number it is, or not? Or should we talk about that? Okay. So let's take this one. Okay, a little later on we're going to add some of these things up. And let's say I wanted you to add up to 249, which is a term in this sequence. When we're adding things up, we will want to know how many terms there are. So we would want to solve for n, since n stands for the number of terms. The way that you find what term it is you use the explicit formula, and you set it equal to the term that you're trying to find what term number it is. So in this case, I chose this one because we already did the explicit formula to save a little time. The explicit formula was this, correct? And I simplified it to be this. So if I wanted to find what term this was, I would say, well, I know the formula is 5n minus 6. I know the term number is 249. Let's figure out what n is. N would be what term we're on. So we would solve that equation. We'd add 6, right? What is it? 51. So then we would know this is the 51st term. That's what that tells you. Okay. Good.